Let's jump right in. If you've ever stared at your graphic display calculator and wondered how to actually turn complex algebra into clear, actionable visual data, you're in the exact right place. Today, we're unlocking the secrets of your GDC for the Cambridge IGCSE 0580 syllabus so you can absolutely conquer linear and quadratic equations. We're going to break down exactly which buttons to press and, more importantly, why you're pressing them.
Here's our game plan for today. We'll be hitting linear equations and graphs, finding points of intersection, the vital y equals rule, graph and quadratic equations, and finally, finding roots and zeros.
Section 1. Linear equations and graphs, visualizing algebra.
Okay, we have to visualize what these equations look like before we even touch a single button. This perfectly illustrates our two main mathematical targets. On the left, check out the classic linear equation, y equals mx plus c. When plotted, that gives you a perfectly straight line every single time. But on the right, we've got the quadratic form, y equals ax squared plus bx plus c. That little squared symbol, it's a total game changer. It morphs our straight line into a sweeping curve. But hey, let's lock down those straight lines first before we get to the curves.
Looking at this data directly from the text, notice how all the linear equations neatly follow that exact y equals mx plus c structure. The m is your gradient, or the slope of the line, and c tells you exactly where it intercepts the y-axis. Take that second row for instance, y equals 2x minus 1. The gradient is 2, so it goes up 2 units for every one across, and it crosses the y-axis at -1. Even a simple equation like y equals 4 works perfectly. The gradient is just 0, giving us a flat horizontal line right at 4.
Moving on to Section 2, Finding Points of Intersection, Simultaneous Solutions.
So what happens when you plot two non-parallel lines on the exact same axes? They're going to cross. Finding that exact spot mathematically is called solving equations simultaneously. But instead of grinding through the algebra, let your calculator do the heavy lifting for you. You just input the distinct equations directly into the interface. Like you see here, we've got y1 equals 2x minus 1 and y2 equals 1/2 x plus 2.
From there, the process is just beautifully straightforward. You simply hit enter to lock those equations in and then smash that graph button. Boom! The calculator instantly turns those numbers into visual geometry, plotting them both simultaneously.
And here's the real magic trick. You don't have to squint at the screen and guess where they cross. By selecting Intersect in your Graph Solve menu, and sure, it might look a tiny bit different if you're using a Casio versus Texas Instruments, but it's the exact same tool. The calculator runs the math and spits out the exact coordinates. For this example, they cross right at x equals 2 and y equals 3. Literally that easy. You just solve the simultaneous equation visually.
Section 3. The vital y equals rule, avoiding the exam trap.
All right, listen up, because we really need to talk about avoiding a massive trap that catches so many students off guard during exams. Pay close attention to this warning straight from the source text. Equations of lines have to be entered in the form y equals. Look, your calculator is incredibly smart, but it's extremely stubborn about its inputs. It literally cannot solve an equation formatted like 2x minus 3y equals 9. Before you even touch the keypad, you have to use a little algebra to rearrange it and make y the subject. So 2x minus 3y equals 9 becomes y equals 2/3 x minus 3. Once you get it into that y equals format, you're golden. Don't let a simple lack of rearranging steal your easy marks.
Section 4. Graphing quadratic equations. Introducing the parabola.
Now that we've totally mastered straight lines, let's step up the difficulty. As we saw briefly earlier, when you graph a quadratic equation where your highest power of x is squared, you do not get a straight line. Instead, you get this really distinct, symmetrical, sweeping U-shape called a parabola. Depending on the numbers, it might open upwards like a smile or downwards like a frown, but it will always have that smooth, parabolic curve.
Section 5, Finding Roots and Zeros, where y equals 0.
Let's explore how to actually find the solutions to these quadratics. The absolute key here is understanding your exam vocabulary. The text points out that all of these terms on screen, solutions, zeros, and roots, they all mean the exact same mathematical thing. They're simply asking, at what x values does y equal exactly 0? In other words, where does the graph cross the horizontal x-axis?
Finding these intercepts on your calculator is a quick 3-step combo. First, just like before, enter your quadratic into the y equals screen. Say y equals -1/2 x squared plus x plus 4. Second, press graph to plot that sweeping parabola. And third, pull up your Graph Solve menu and select the tool called Root or Zero. The calculator prompts you, runs the numbers, and calculates the precise x values where the curve slices through the line.
But here is where it gets super interesting. Check out this slide. It brilliantly illustrates a quirky thing about parabolas. Some of them, like the one on the left, cross the horizontal axis twice, giving us two distinct roots, like -2 and +4 here. But look at the one on the right. X squared minus 3x plus 4 equals 0. When you graph that, the entire U-shape just floats above the line. It never crosses the x-axis at all. Because it never physically touches where y equals 0, this equation has absolutely no real solutions.
Which brings us to a fascinating little breadcrumb the text leaves for us. It says that while these non-crossing equations have no real solutions, there are imaginary solutions. So if the graph doesn't physically cross the line we can see, what kind of mathematical secrets are hiding in those imaginary solutions just waiting for you in advanced math? It's a perfect reminder that it's like a giant puzzle, and there's always another layer to uncover. Keep practicing with that graphic display calculator, always remember the y equals rule, and you'll be conquering these exam questions for sure.